Good morning, everyone, and welcome to Autodesk Virtual Academy, brought to you by KETIV Technologies. I'm Nigel Mbayak, Customer Success Manager here at KETIV. I'd like to welcome all of you back, for those of you who are returning. And for those of you who are new to our learning community here, definitely welcome to AVA. Today I'm joined by Alvarez, one of my colleagues here at KETIV. How's it going, Alex?
Not too bad, not too bad. Enjoying some gloomy weather, actually, here in Southern California. So.
Yeah, it's a little bit rainy. It's always a little bit different. So today we're going to be going over some really key features in Inventor HSM. And if you don't know what HSM stands for, correct me if I'm wrong, HSM stands for high-speed machining. And that is the CAM tool that is included with the Autodesk Product Design and Manufacturing Collection. And it's integrated directly into Inventor. Alex is going to go over some of the benefits of using HSM as opposed to maybe some other third-party CAD tools, as well as why you should be using this in your workflow if machining is part of that. So if you do have any questions, definitely let us know in the GoToWebinar chat panel or the YouTube chat panel if that's where you are. And we'll go ahead and address those when we get to that point. So Alex, go ahead and take it away.
All right, perfect. Thank you for that, Nigel. All right, so as always, we do want to start off with the why to the webinars, right? There has to be a reason why we do these every week. First and foremost is just to share knowledge with you guys, right? We want to make sure that the whole community, everyone that uses Autodesk products is understanding these products in a deeper level, right? For this webinar in specific, the why is going to be how to understand the different toolpaths inside of Inventor HSM, right? So there are a few toolpaths. Again, for this webinar, we are going to be focusing on positional and simultaneous machining. We're also going to go over what that means exactly, right? So some people get confused and they start confusing 5-axis machining with positional. And again, we want to go kind of into detail what the differences are there. Again, that's going to provide you some more efficient workflows, right? So again, 3+2 machining, it's going to eliminate really the need to change the work setups. Again, maybe you have a part that has some weird angles. You don't have to create some sort of fixture for that. Again, when you have the ability to really use the 5-axis to its full capabilities, now you're eliminating certain work setups and really making your workflow much more efficient. And then lastly, we are going to be talking about some the post processor inside of Inventor HSM, right? So if you guys aren't familiar with the post processor, that's really what's taking care of the toolpaths that you program and converting it into a language that your machine is going to understand, right? So not all the machines are the same. And again, we are going to be covering, what are the differences between some of these different post processors. Like Nigel mentioned, it is already included in the Product Design and Manufacturing Collection. Now, what does that mean for you? Again, you are already going to have the CAM tool built into your, let's say, Inventor Professional, right? So again, it's going to be one single platform. You don't have to really transition out or really export any sort of data. Once you're done modeling or once your design engineer is done modeling, you can just quickly transition over to the CAM tool and then start programming your part right away, right? So again, that just eliminates the need for maybe some sort of issues with the data translation. Oftentimes what we see is maybe some of the CAM tools can only export or import certain file types. Again, with Inventor Professional, you're going to be modeling and programming the toolpaths all in the same tool, essentially.
Yep, so you don't need to worry about having to, generally the word step out files is used a lot in these CAM workflows when you're talking about, stepping out your file, exporting to step from your CAD tool so that you can open it in, something like a master cam or a Gibbs cam or something. If it doesn't automatically detect the file translation from native Inventor SOLIDWORKS Pro data.
Right, exactly. And so here we have some of the Inventor HSM toolpaths, right? So when people automatically think 5-axis toolpaths, they think, okay, you go to the multi-axis tab, you hit the drop down, and you just see those 2 or 3 toolpaths that are included with the, under the multi-axis tab. But what a lot of people don't know is that some of the 3D toolpaths already have 5-axis capabilities, right? Now, it's not going to be true 5-axis. It is going to be 3+2. Machining, right? So what that means, again, going back to positional, it's going to position the part in a certain orientation, right? Depending on how your feature is essentially built onto the part, it's going to make that face or that feature perpendicular to your tool axis. It's going to machine that feature, and then it's going to rotate to the next operation and then machine that second feature, right? So again, you do have options or capabilities within the 3D toolpaths or even 2D toolpaths as well, right? To have some sort of 3+2 or simultaneous 5-axis toolpaths. Now, under the 3D milling toolpath, the contour toolpath actually does have multi-axis capabilities. So if you go under the passes tab and you work your way down, you are going to see a multi-axis tilting option. Again, that's going to allow you to essentially tilt the tool a little bit if you have some sort of collision with the holder, or maybe the shaft of the tool is going to be hitting the top of the part. Again, you can have a slight tilt to the tool and then avoid those unnecessary collisions, right? What you also have the ability to do is turn on beta mode inside of Inventor HSM. Now, what beta mode does, it gives you some sort of extra functionality. You guys do have to keep in mind, though, it is still being tested, right? So again, you guys want to make sure that you try this at your own risk. But one of the functionalities, though, that beta mode brings to the table is if you take a look at the swarf toolpath over here on the right, or the dialog box, you have the option to essentially lock one of the axes, right? So instead of making it a true 5-axis toolpath, you can lock that one of the axes. Now it makes it a 4th-axis toolpath, and now you can use it, for instance, on some sort of rotary table or something of that sort. Now, of course, in the multi-axis tab, you do have these extra toolpaths, right? So you have the swarf, which is the full 5-axis multi-axis contour toolpath as well, and the flow toolpath, which is fairly recent to the toolpaths here as well. So the ones we're going to focus on today, of course, is going to be 3+2 positional toolpaths and the swarf and the flow toolpath as well. So as always, we do want to make sure that you guys ask questions. We want to keep this as interactive as possible. So again, any questions that you guys have, feel free to ask away, and I'll do my best to answer some of those questions, right? So let's go ahead and jump into Inventor here. And again, this goes back to having that integrated workflow, right? So notice how we do have essentially our vise or our work holding here modeled inside of Inventor. Now, a couple benefits to having this modeled or this assembled in Inventor, especially when you're working with 5-axis toolpaths, it starts getting a little scary, right? With some of those rotations, the transitions, you want to make sure that you don't have any collisions, right? So once you start diving a little bit deeper into 5-axis toolpaths, the risk of having some sort of collision really increases, exponentially, right? So you guys want to make sure, take the time, make sure that you either model something similar or you just bring in the assembly of your vise. That way you guys can see exactly what's going to happen when your tool is rotating. Now, we don't have machine simulation, right? So what machine simulation means is you import the machine model, and you can actually see the part rotating in respect to to the tool that you're machining with. But what we do have is just a standard simulation. But again, it's still going to show the tool itself rotating, right? So you still get some clear understanding or visual of what's happening when you're machining this part here. Now, again, this is going to be a 3+2 positional part. Now, reason for that is because, again, we don't really need any simultaneous 5-axis for this. But also keep in mind as to how long would it take if you guys didn't have the 3+2 toolpaths. Again, notice that these pockets here are at some sort of an angle. So you would have either some sort of a fixture, to kind of position it that way. And then, the fixture for this other pocket over here, then you have to flip it. And then you have a few more pockets here. So you would at least have, 3+, 4+ different work setups in order to get this part done. Again, let's go ahead and take a look at how many setups it would take to essentially create this part here, right? So we already have setup 1 created. We do have a few toolpaths already, right? So we have the face, we have a roughing operation, 2D pocket, 2D console. What we can do here then is just simulate just to see what we have going on so far, right? So hit simulate. You have the option to turn on the stock here. How fast do you want the simulation to run, right? So you can control that by just kind of dragging this to the right a little bit. And here we have it, right? So again, we pretty much took care of the standard, right, features here. So now let's go ahead and start focusing then on these angled pockets for a little bit. Now, when working with 3+2 toolpath, it's going to be extremely easy, right? So what I mean by that, again, it's going to be found under 2D toolpaths, right? So a lot of you are probably wondering, well, why, how is that going to be, under the 2D toolpath? In this case, if we select then, let's say we want a pocket operation, brings in the tool, right? So again, we are going to be working with these 5 tabs here. Now, these 5 tabs, whether you're working with 2D toolpaths, 3D toolpaths, or even, the multi-axis toolpaths, you're always going to see this workflow. So things aren't going to be changing around on you. You are going to be getting some more functionality in the dialog boxes down here. But again, the workflow is going to stay consistent, right? So again, just making your life a lot easier as you're programming some of these parts. So as always, selecting the tool first, right? So in this case, I want to probably start off with some sort of a 1/4 inch flat. Select this tool here. Next tab over is the geometry tab, right? So this is where it starts getting a little bit different. Again, we want to machine this pocket here. So if we, as standard, just select the pocket, take a look at what happens, right? So it projects that pocket onto our XY plane. Right, so what we want to do here then is make sure that we check tool orientation, right? So then that's going to change essentially how our work corner system is oriented. Check that on. Notice now that it kind of gave you somewhat of a preview for the work or the new tool orientation, but it's still not quite right. Right, so now you want to make sure that you select a face that's going to be perpendicular to that tool axis. Right, so in this case, it's going to be this face right here. Click on that and notice that we now get a much better representation of that pocket itself. Right, so one more thing that you guys want to take care of here is in the heights. Right, so the top height, we don't want it to start from the very top over here. We can make that a selection and then select our top reference here. Right, so we can either select this point here. Again, the feed height is going to be 200 thousandths above that, so we're definitely going to clear that. From there, you can just click OK, and notice now that we essentially got our positional toolpath there. Right, so again, it's very straightforward. You just have to keep in mind, where that tool axis is going to be perpendicular to, and you make sure that you just select that, either a flat face or maybe an axis. Sometimes you do want to maybe create some sort of reference geometry to make your life a little bit easier, and just keep on going about it there. So now what I want to do is maybe finish that pocket there. What I can do then is do a some sort of a 2D contour, but keep in mind as to what's going to happen if I select the 2D contour, right? So I'm going to have to select the 2D contour, maybe reselect the tool orientation, and then the pocket itself, right? What I can do is select a derived operation set, right? So if you guys aren't familiar with a derived operation, essentially what it does, it takes into account all the options that you have selected for that toolpath. The only difference, though, is that it creates a different toolpath based on your selection, right? So in this case, I want to use a 2D contour. So it selects a 2D contour. Notice how it also automatically brought in the tool at the correct angle, right? So if we take a look here, notice that the tool orientation is already selected. The contour is already selected as well. If we go to the heights, it has the correct height here as well. So that's one way that, again, you guys can really make your programming much more efficient, is by taking advantage of those derived operations, right? So really from here, you can just click OK, and it creates that 2D contour toolpath. From here, you can either keep on going around the pockets here. One way that you can kind of take care of all these pockets is by using some sort of a circular pattern. So of course, we would have to still program this part or this feature here, but let me just create a pattern based off of these 2 toolpaths. Right, so going over to the top, selecting pattern. I don't want a linear pattern. In this case, I want a circular pattern. The axis is going to be that axis there. And notice that it automatically created our toolpath over here on the other side, right? I can go ahead and keep it at order by operation, select OK. And we have those, those 2 pockets essentially programmed. All you really need to do is do the same thing for this pocket and add it to this circular pattern, and you're pretty much done with the part. Now, when it comes to drilling, right? So drilling is going to be actually even much more easier to kind of go about it. Reason for that is you can just select the hole itself, right? So again, you still have to enable tool orientation, select the hole, and it automatically knows which way to go, right? So in this case, still keep in mind that the z-axis is pointing down. You want to make sure that it's still pointing in the correct orientation there. Make sure that you select the hole here. And what's nice about this is that it gives you a preview, right? So here I can see exactly how deep the drill is going to be going, and I can also see that it's not the correct drill size, right? So again, going back to the tool, making sure that you select the right tool here. In this case, it's a 1/2 inch drill. And then for the bottom height, right, you want to make sure that the tip of the tool does go through the bottom of that feature there. Drill tip to the bottom. And make sure that you have some sort of breakthrough depth there as well. Hit OK. Right, so you would pretty much, again, add that to the pattern. And again, just kind of go about it. Keep on going about it for the rest of the part, right? What we can do here is let's go ahead and simulate, right? So just so we can see exactly what's taking place. So again, we've already seen that, so we can skip some of these. Right, so now notice how it again shows the axis here, and it shows the tool tilting in the correct orientation, right? And then there's a drill there, and then the drill there. Right, so it's pretty straightforward. Again, 3 + 2 isn't too difficult. And again, you guys already have this capability, right? So if you guys are looking into maybe getting a machine that has either 5-axis capabilities, or you guys are still on the fence of whether you need it or not, I always recommend people, if they have the ability to get one of those machines, by all means, go ahead and get them, right? Again, because imagine how many different work setups you would avoid by, again, having the 5-axis capabilities. All right, so that's been the 3 + 2. What we can do here is post it. All right, so let me see if I can just post these toolpaths here. Again, the way you would post it is pretty straightforward, right? So again, same way that you would go about posting a regular 3-axis toolpath. In this case, we already have a few posts that have 5-axis capabilities, right? So in this case, let's say we want to use the Haas T750. Really, you would just have to hit post, make sure that you have the correct program number. And then here is your program, right? So the extra 2 axes in this case is going to be your B and your C axis, right? So essentially those are going to be your rotation around, either the Y and the Z axis. Typically the A axis is what rotates around the X axis, right? So again, that's also one thing that you guys want to keep track of, is how are you setting up your part, right? Because if you set it up incorrectly, then you are going to get the incorrect rotation when it comes to posting out. And either the machine's going to error out, or you are going to get a rotation in the wrong axis. So again, you do want to make sure that when you're creating your setup over here, you have the correct orientation for your Y and your X axis. All right, so that's been the positional. Again, last part that we're going to focus on here is going to be this little cube here. Pretty straightforward part. But it does have that little curved surface, right? So again, you can probably do that again on a 3-axis machine, but in this case, we have 5-axis capabilities. So let's go ahead and take advantage of that. We can go ahead and simulate again, just so we can see what we have going on. Let's get that one and our pocket operation, right? So essentially now what we want to do is maybe take care of that little bevel that we have and the surface on the top, right? So let's go ahead and move forward here. Again, we have tool 1, right, taking care of that 2D pocket. Now, typically, if you didn't have, the 5-axis capabilities, you would probably use some sort of either ball end mill and use a scallop toolpath maybe to go around this bevel. But in this case, I want to take advantage of the swarf toolpath, right? So I don't want to make any tool changes here. I want to use that same tool one that I was using. So let's go ahead and use the swarf toolpath. Now the swarf toolpath is going to be extremely useful when you have features that are relatively similar to this, right? So if you guys ever want some sort of explanation of the toolpaths, just hover over some of these options, right? So again, get familiar with these toolpaths and really start visualizing or understanding, when that toolpath is going to be, pretty beneficial to a certain feature on the part. So again, in this case, we have the swarf toolpath. Kind of shows you a diagram there of what's going on, right? So again, some sort of beveled edge. So we want to make sure that we use still tool number 1. Next tab over is the geometry tab, right? So again, we are in the multi-axis toolpath, but it still gives us the same five tabs here on the top. Now for the swarf toolpath, you have a couple options of when it comes to driving this toolpath, right? So you can either drive it by contours or you can drive it by surfaces here as well, right? So in this case, I find it usually a little bit better or just easier for the user to just select the contours themselves. Again, so drive mode, select contours. In this case, you can do contour pairs, right? So by contour pairs, it's essentially saying, okay, give me 2 contours that define the bottom of the tool and the top of the tool, right? So in this case, the bottom of the tool is always going to be the first selection, right? So by keeping that in mind, then we want to make sure that we have this set to be essentially the bottom portion, right? So our tool is going to be essentially facing or in this orientation like this. Notice that it changed that contour to a blue color. If I select now the top contour here, it made that a yellow selection, right? And again, we have beta mode here enabled, so we do have the option to lock one of the axes. But in this case, again, we do have full 5-axis capabilities. And really, with the swarf toolpath, that would pretty much be it, right? So you click OK, and we, right off the bat, have a full functional 5-axis toolpath, right? So again, how easy was that? You just selected the tool, selected the 2 contours, and you already have full 5-axis capabilities, right? So again, other softwares you may have, you usually create some sort of surface or reference surface. Maybe you have to create an axis kind of indicating to the software, okay, this is the orientation that my tool is going to be set up in. But again, with Inventor HSM, pretty straightforward when it comes to creating some sort of 5-axis toolpath.
And then Alex, just real quick question too, is if you didn't use that swarf toolpath and you use the ball end mill to do that bevel there, how much longer do you think it would take than just this?
Oh, that would probably take at least a good 5 minutes, 10 minutes, depending on what kind of machine you have, how fast you want to run it. But yeah, you would have the scallop toolpath, and then you would have a small step over. Whereas this swarf toolpath, right? If you go to the machine time here, you can see how long it takes, 30 seconds, right? So again, this is a rough estimate, but again, it's still going to be much faster than creating some sort of a different toolpath around that.
Right, because I'm assuming like if you use ball end mill there, it would just go in circles or I guess squares around that thing until it got to the bottom.
Exactly.
You'd have to pass everything 3, 4, 5, 6, depending on the step over, right? How many times?
Exactly. Yeah.
In this case, it goes over. Looks like just once.
Yeah, just one time. Again, you can make it 2 times if it was removing a little bit too much material. But that's still going to be much faster than having that small step over go across that bevel there. One thing to note too is that if we simulate that, right? So simulate the toolpath again. It's already showing that tilt automatically, and you can control the tilt, by the way. So again, you have that functionality. But in this case, let me go ahead and simulate. Right, so notice that the bottom of the tool again is keeping in contact with that bottom contour that we selected. And again, it's following that because that's the selection that we made. In this case, I would probably want to maybe have some sort of an offset here. So a couple options, right? So sometimes it's easier to just go into the toolpath, see what kind of options we have. If we go into the passes tab, notice that we have a tool offset, right? So if we give it some sort of an offset, let's say 200 thousandths in this case, right? So you do have the option to do multiple passes as well. And then you have, your maximum tool axis sweep here as well, right? So you do have some control when it comes to actually controlling the sweep and the angle of the tool itself. So now if we simulate this once again, notice that we do have that 200 thousandths offset from that bevel there, right? So sometimes it's not that easy or it's not as intuitive depending on the part that you're working with. So another option would have been to maybe create some sort of reference surface, right? So make the surface an offset surface, actually create an offset there, and then select the contour from that surface instead of following this beveled edge. All right, so that takes care of the swerve toolpath. Now let's go over to the last portion of this part. In this case, we want to do a flow toolpath, right? So again, you'll see that we have the flow toolpath here in multi-axis milling, but notice where else it comes up, right? So it comes up and under the 3D milling toolpaths, right? So again, let me go ahead and select this one just so you guys can see. So again, by default, that flow toolpath is actually a 3-axis toolpath, right? So even though it's found under the multi-axis milling, it's going to be just a straight 3-axis toolpath, right? So let's go ahead and see how that looks like. In this case, I'm going to use a 1/4" ball. And again, with the flow toolpath, it's just going to be as easy as just selecting a surface, right? Notice that you have the arrows kind of indicating, along which vector are you going to be machining. So either the U or the V vector. In this case, you can say V, right? So it switches it in orientation. And then you have the number of step overs, right? So in this case, you want to start off small. Typically, you don't want to really bog down your computer when it comes to trying out a new toolpath. So make sure that you have the first off a decent looking toolpath, and then after that you can start controlling some of these step overs here. So after that, you can go ahead and click OK. And we have the flow toolpath here, right? So again, it has a pretty wide step over, so I probably wouldn't use this. But again, let's go ahead and simulate just so you guys can see how the tool is acting, right? So again, notice that it's acting more like a parallel toolpath, right? So in this case, it's just going, straight across the part. It's machining with the bottom, right, or the center of the ball end mill, which again, it's probably going to leave us a pretty poor surface finish here. So what I want to do then is add a small tilt to that tool, right? So again, if we go back to the toolpath under passes, now we can enable the 5th axis capabilities, use multi-axis tilt. In this case, depending on whether you want a forward tilt or sideways tilt, right? So this ultimately just means, whether you want a lead angle or a lag angle on the tool. In this case, I just want a sideways tilt of roughly 10 degrees. And then in this case, I would probably want to go ahead and increase this as well, right? So hit OK. Right, so now we have a much nicer toolpath. Again, we can create a surface here that extends this portion here, right? So instead of machining, up to that little beveled edge, just increase the surface and then have the toolpath extend a little bit. But let's go ahead and simulate this real quick. Notice that now, though, instead of being straight up and down, right? Now we have that small tilt, the tilt of 10 degrees added to the toolpath, right? So now we see that it's actually indeed a full 5-axis toolpath, right? So if we go ahead and we actually post this toolpath, right? So post process, again, UMC 750 onto our desktop. And if I go back here, right, so take a look at what's happening down here, right? So now instead of having, some sort of XY toolpath and then the rotation, now we actually have the full 5-axis working simultaneously, right? So that's what I mean by, or that's what people refer to simultaneous 5-axis. In this case, the toolpath or the tool is going to be working in all the 5 axes that the machine has to offer, right? So again, it's pretty intuitive. There's nothing really too difficult when it comes to programming some of these parts. And it's just a matter of what feature the part has and which toolpath is going to be the best toolpath that represents that feature or kind of follows the flow of that feature, right? Now let's go ahead and dive a little bit deeper into the posts here themselves. So you'll notice that you have the Haas UMC 750. Again, the posts are open for you guys to really dive into. If you guys are familiar with JavaScript, you guys can go in here and maybe make some changes if you wish. But again, if you open config, notice that you have the entire post available to you, right? So again, this is what's taking place in the back end when it comes to programming a part. Again, this is what's going to control the XY movements, what's going to control the rotation of your machine, how your tool changes are getting carried out. So one thing that you guys do want to note, let me look for it here, is going to be this section here, right? So I believe either Matt Nichols or someone from Autodesk has a pretty extensive video on post-processing. But again, the main sections that you want to focus on are the on-open, on-section, and the on-close portions of the post, right? So again, on the on-open, notice that we have this little function here, right? So if true, UMC 750, notice that we have then the B axis and the C axis taking place, right? If I close this and open up the standard Haas post, open config, and again, work my way down here. You can Control F and just find it much quicker here, but okay, so here we have function on open, right? So notice now the difference, right? So it's now not if true, now it's set to false. So by default, this post has 5-axis capabilities, but again, you would have to go in here and turn some of these features on. What you can do is maybe reference the Haas UMC 750 post and kind of see some of the options that they turned on or that they enabled. Again, you do have to keep in mind though that every machine is going to be different, so you have to keep in mind the machine dynamics, how the axes are going to be rotating around either the X or Y axis or even the Z axis. So that's something that you do have to keep in mind when it comes to kind of editing the post. But I just want to let you guys know that most of the posts here do have the ability to work with 5-axis toolpaths. You just have to go in there and turn on some of these features themselves. So again, let's go back in here. Just a quick summary, right? So again, the differences between a 3+2 toolpath and a simultaneous 5-axis toolpath. So again, it's not too difficult to actually program some of these toolpaths. So when people hear 5-axis, they automatically start thinking in their mind that it's going to be an extremely difficult process. But it's really not. It's very intuitive inside of Inventor HSM. It's easy to follow, and with a little bit of practice, you can definitely start programming. Maybe even in the same day, right? If you guys weren't familiar with simultaneous 5-axis or 3+2 programming, there's some toolpath selection, and then when it's optimal to use a specific toolpath, and then finally posting out to your machine. So again, at this point, if you guys had any questions, please feel free to ask away. Again, that's my email. If you guys ever have a question, either regarding a post, maybe your post is already out when you're posting out a 5-axis toolpath, feel free to reach out. I can definitely provide some guidance and probably answer some of those questions as well.
Certainly. And Alex, real quick, if you want to just jump into Inventor, I want to emphasize too the fact that this is all in Inventor, right? Alex could go straight into the 3D model tab, and if he wanted to add an extrude to this or do anything, he could. And then the fact that the toolpaths too are adaptive based on if the geometry in here changes as well. So I just kind of want to emphasize that too, where Alex didn't have to save this file out and then open it in another program. Literally, the only programs open on Alex's computer right now are PowerPoint, Inventor, and the tool we're using to broadcast all of this. Yeah. So kind of really want to emphasize that. The fact that it is an in-canvas workflow being built straight into Inventor. The same thing kind of works along the same lines with all of the simulation and all of the nesting too. It's all built into Inventor. You literally open Inventor and you just use some of these external environments, and the CAM one just happens to be one of them. So I want to reiterate that because I know that is a really that's a really big hitting point when we're talking about some of the advantages of using some of these in-canvas workflows as opposed to using third-party tools or some of the other Autodesk built tools that maybe you have to export this stuff out to. So just an aside on that as well. All right, let's go ahead and take a look at some of the questions. Like I said, if you do have any, go ahead and type them into the chat panel, or go ahead and type them into whatever comments tab you're using. Right, I know some people are watching on some other live stream services, so if you do have those questions there, let us know. Let's see here. It looks like there's a couple of questions about people having whether or not we have posts for certain machines. Alex, what's the best way to check if that post exists for HSM already?
Yeah, so actually one way that you can go in there and check, again, it's if you go into the post-process or post-process window here, you can go directly into the Autodesk HSM post library, right? So if you click on that, it redirects you directly to the Autodesk website, right? So here you actually find all the different posts that Autodesk has to offer, right? If you don't find it here, what we usually do, we do have kind of a process or a guideline for people to send in their post processors. Is maybe there's a post in here that's very similar to what you already have. What we can do is make those quick modifications, and if it's not too extensive, then we can just send it back out to you. But again, usually Autodesk already has all the posts here available. Another really good place to look in is the HSM post forum. A lot of people tend to share their posts and really help others out. So that's also a pretty good place to start. Is go to the HSM post forum and see if anyone else out there has a similar post to what you have.
Yep, certainly. I know a lot of people that I have pointed towards the direction of the forum. A lot of the Autodesk employees are in there.
Yeah.
A lot of people who've been developing the tool even are in there as well, helping out people. The community is really super awesome. Not just for HSM, but for pretty much anything Autodesk related. I know I use it a ton for the automation stuff. Our posts in HSM, so I guess this is a continuation of the same question. Are the posts in HSM the exact same posts as exist in Fusion 360?
Yeah. So they're going to be the same thing. Again, you always want to make sure too, though, that you have the most up-to-date post, right? So take a look at the Fanuc post. It was changed 6 days ago. You can go into the recent changes and figure out, what some of those changes were. But yeah, they're going to be the same exact post. Again, for those of you that aren't aware, HSM is actually built into Fusion 360, right? So the toolpathing kernel is actually what drives the CAM kernel inside of Fusion 360.
It's all the same, but different, but same.
Yeah. So it gets a little confusing there. But yeah, they're going to be the same exact posts. And like I mentioned, you do want to make sure that you have the most up-to-date post here as well.
Cool. And then there's a couple of questions about HSM inclusion in people's packages. In regards to the collection, you have full HSM Ultimate, which is the 5-axis HSM. If you don't have collections and you have suites, you don't have access to the 5-axis capabilities Alex showed today. You have access to HSM Express. And Alex, can you kind of give us the lowdown on the difference between HSM Express and HSM Ultimate?
Yeah, essentially you just don't get the 4th and 5th axis capabilities, right? That's going to be the biggest difference. And again, that includes the tool orientation as well. So instead of having that little dialog box that has the tool orientation, now you're not going to be able to orient that work corner system anymore, right?
Yep, and if you have any particular questions about what you have in particular, if you don't know if you have suites or collections, or you have the ability to change from one to the other, so on and so forth, please reach out to us. We'll be able to take a look at those accounts and see what options you have, right? Whether or not you have it, what are your options to getting it, if possible. And sometimes it's actually cheaper to get it than not have it, which is crazy. And then let's see here. What's the best way to extend a surface, like the top surface you milled with the ball end mill at the end there?
For that, I would probably just create some sort of an offset surface. So let me see if I can go in here. 3D model.
Just emphasizing the fact that Alex literally clicked the other tab to get to the model.
Yeah, you can do, let's see if you can do a thicken offset. And then let me just get out of this model stuff. Yeah, so thicken offset and then select that surface there. Notice that it's trying to, to create some sort of solid. What you would do here though is make sure that you select surface, right? So now it created a surface and it's creating at 0.1. Nice thing about surfaces is that you can do a distance of 0 essentially. Hit OK, and now we have that surface created, right? So what you can do from here is hit extend, and then it selects certain parts of the surface here. So if you just wanted to create an extension along this edge, just select the edge, and then it creates that extension. But again, that applies really to any feature, right? So again, you can do a thicken offset, and then just make sure that you select surface and have a distance of 0, right?
Yep. Let's see here. I'll read the question.
Okay.
You'll probably be able to understand what they're asking because this is not my expertise level. Do you offer mill turn capabilities for lathes with live tooling and dual spindles?
Yeah, so we actually do. We do have the ability to do mill turn. And again, that is going to require the fourth and fifth axis, right? Because you are going to need essentially the tool orientation inside of the tool paths. But yeah, you can definitely do mill turn. And for dual spindles, we have a little bit of functionality. Again, if you're constantly doing dual spindle, then I probably wouldn't recommend it. But you do have some options here, right? So if you have a secondary spindle and you just want to machine on the secondary spindles, so you can definitely do that as well.
Yep. And if you have any further questions about that, definitely reach out to Alex. He can get you more details specifically about what's going on. HSM is not the only cam tool we have as well.
Mm-hmm.
There are some other tools with some, I would say, more advanced functionality.
Yep.
So if you have any questions about that, let us know.
Mm-hmm. One thing I also forgot to kind of go over is how to turn on the beta mode inside of Inventor HSM. The way you turn that on is you hold Control Shift on your keyboard. You hit, you right click, and over here on the bottom you should see beta mode. So if you do want to kind of experiment with that, again, just try it at your own risk, right? But you do have the option to turn on beta mode and look through some of the advanced functionality, right, that Inventor HSM has to offer.
Awesome. That helps a lot. And this is a really cool question, and I think we can emphasize this a little bit. Does the code attach to the .ipt file? So the Inventor part file itself. So Alex is doing all of this in the Inventor part file. Save the part file. All of the toolpath setup and stuff is in that part file.
Mm-hmm.
The actual post that Alex created, that NC post, is in another file. So once you hit the post button, which is that post process button next to the simulate button in the toolpath ribbon, that creates another file that you'll send somewhere else.
Mm-hmm.
So you're still going to send an NC file to your controller or your machine itself. But I guess you could say yes and no, the code is attached to the IPT
Mm-hmm.
file.
Yeah, and reason why they wouldn't attach the code is because, again, we have this toolpath here, right? And you can essentially program it on dozens of different machines, right? So the code is not always going to be the same. So that's why they don't necessarily attach the code to the part.
Yeah, the code's not attached to the part, but the setup is attached to the part.
Setup and the toolpaths are always going to be there. Yep.
Yeah, because you can, once you hit that post process, you have the ability to export into a million different posts. Not a million, it's a couple thousand, I think. But anyways, that's great. Another question here. Can you manage stock models into HSM? I think I need a little bit more clarity on what you mean by that. When you're talking about stock models, I know that to create the stock for this, that is in the original setup, and Alex literally selected box.
Yep. In this case, though, let's say we were to have some sort of second operation. What a lot of people like to see is the the stock that's left over from the first setup. So what you can do is hit simulate, right? So run through the entire thing here. So let it load up a little bit. So again, the 5-axis toolpaths do take a little bit more processing power, right? But once you have the final, essentially, I guess you would say the final stock representation, you can right-click, go to stock, and then save stock, right? So if that's what kind of you were referring to, yeah, you do have the option to either import some sort of predefined stock, right? So if you're working from some sort of forging, you can import it here and then select that to be your starting stock. Or if you're working with a second setup, just save the stock from the first one and just carry on to the second setup.
Yep. And if you're looking at when you're doing some of these second operations, needing some sort of from fixtures for that, Alex has done a couple of HSM videos and Fusion 360 videos showing how to create some of these negative fixtures for some of these parts when you have to maybe turn them over. If you are using maybe just a 3-axis machine, for example. How do the links work with Vault? Probably need a little bit more understanding of exactly what you mean by the links. The part file has all of the information in it, right? So it goes straight into Vault as normal, so on and so forth. The actual NC file, you can put into Vault, but it's not tied to this model. They act completely separately of one another. So you can load it into Vault, that NC file. I've seen some people do that before. They create the NC file, they put it in the Vault working folder, and then they load that thing straight up into Vault in maybe the same directory as this. You might be able to, I don't know if you can leverage some of the API to do that for you.
You actually might be able to do something.
You probably could do something like that. So let us know, Joseph, if you have any questions about how all of this works with Vault. Literally, the part file goes in as normal. Some people put the NC file in Vault too. I've seen a lot of people not do that though as well. So
yeah,
it really depends on what you're trying to do. Does HSM create a setup and tool list?
Yeah. So if I'm understanding it correctly, you do have a setup sheet option over here on the top, right? So if I've seen a lot of people use it if they have multiple shifts actually on the, at their job site, they create these setup sheets. And the nice thing about it is that it creates images and it creates a detailed list of all the tools that's going to be used. And then it saves it out either as a PDF or HTML, so you can even open it on your phone and have that second operator know exactly what he's going to be machining and where all the work corner system is going to be at. So yeah, you definitely have the ability to do that.
All right, cool. I think that's just about it for questions. I'll wait another 30 seconds or so while I'm making announcements to go ahead and answer the rest. But I can't. All right. Boom, boom, boom. I have a link to share with you all. Let me go ahead and copy this out and post it into the chat. And paste. Send to entire audience. Cool. So the link I just posted in the chat bar, if you can all start clicking that if you need more information on it, is information for the AutoCAD electrical webcast we're going to be doing. Alex, if you want to click and just bring that up on your screen,
yep.
that would be cool too. So we are hosting a AutoCAD electrical webcast. A lot of people are starting to use electrical, or there's been a lot of buzz around creating some of this electrical documentation with AutoCAD, wire diagrams, so on and so forth. If you want to learn more about it, feel free to sign up for the session itself. If you need more details on what's in it, the description is there on the left. So be prepared for that. That's coming up in a couple of days here. So I hope to see you all there. Just wanted to make that announcement for that. Let's see here. I think that's it for those announcements. For those of you who do have VaultCare or Streamline, be on the lookout for a couple of emails or phone calls from your customer success managers about the upcoming Jumpstart session, which is that onboarding for AutoCAD as well as Inventor. And keep a lookout for the productivity training session this month, which is going to be all about finite element analysis. So that 4-hour training class on FEA, we're going to be using both some of the Inventor Pro functionality and Nastran InCAD functionality. So be on the lookout for that. If you want to know and get more information on what that is, maybe if you're not a Streamline or Vulcare customer, please let me know and I can answer those questions for you. Cool. I think that's it. I didn't see any more questions come through. Alex, did you see any?
No, I didn't. Yeah, but let me go ahead and put up my email again. Again, guys, if you guys want to reach out, there's my email. Feel free to ask away any questions you have on Inventor HSM.
Yeah, certainly. Even if you've never talked to Alex before, if you're not one of our customers, please reach out. We want to be able to help everyone in the community start leveraging a lot more of these tools, and just make it a more powerful workflow. Save time, save money, be more efficient. It's really the goal here. So that's why we do these webcasts each and every week. We want to make sure that everyone's using the tools to their capabilities. So again, I'd like to thank all of the audience for joining us today. And then also, I would like to thank Alex Alvarez for being a part of AVA this week. And yeah, we'll see you in a couple of weeks, Alex. Cool. Thanks, everybody. We'll see you soon. And have a great rest of your day. Bye-bye.